Let's see this question. We want to find all roots of this polynomial degree 4. Degree 4. So which means at the most, this function can have 4 roots. So how do we do it? We're going to use rational root theorem. Okay, rational root theorem says all the possible rational roots of f comes from the quotient of factors of 16, negative 16, or 16 divided by 2. So let's try simple ones. So let's use a synthetic division or short division. So take down the coefficient of every one and also the constant term. So I have 2, this is 1, then negative 4 again, then negative 16. So then we're thinking, okay, factors of 16 and factors of 2 has 1 in it. So let's try 1. Let's try 1. So we pull 2 down. 1 times 2 is 2. Add those two numbers. Add 1 to 2, get 3. 1 times 3, you get 3. Add negative 4 with 3, you get negative 1. 1 times negative 1, get negative 1. Then negative 4 plus negative 1, get negative 5. 1 times negative 5, negative 5. Add those two, we don't get 0. If we do not get 0, that means 1 is not a possible root, all right, or a factor. So when we do x1, we're thinking of x minus 1 is a factor of this polynomial 4. So now let's try negative 1. Well, negative 1 times 2, that's negative 2. Negative 2 plus 1, we get negative 1. So negative 2 plus 1, we get negative 1. Negative 1 plus, times negative 1, we get a positive 1. Negative 4 plus 1, we get negative 3. Negative 1 times negative 3, positive 3. Negative 4 plus 3, we get negative 1. Negative 1 times negative 1, positive 1. Again, negative 16, add 1 is not 0. So that means x plus 1 minus 1 here means x plus 1 is not a factor. Then we keep trying. Let's try 2. Because factors of 16 has 4 in it, right? And the factors of 4 divided by 2 is 2. So let's try 2. 2 times 2, 4. 1 plus 4, 5. 2 times 4, 10. 10 plus negative 4, positive 6. 2 times 6, 12. 12 minus 4, 8. 2 times 8, 16. Bingo, get 0. So that means we can factor the function into x minus 2 times 2x cubed, because this 2 is the coefficient of x cubed, plus 5x squared, plus 6x, and plus 8. Plus 8. Now, if we want, we can keep trying synthetic division. Or, if you will observe, we see obviously we can factor this, right? So the common factor of these two terms, we have 4 terms. We can group them 2 by 2. And this 2 has a common factor of x squared. And this 2 has a common factor of 2. Oh, okay, we won't be able to do that. Okay, it's okay. We won't be able to factor this. So let's keep trying. So we have this. Let's keep trying. Let's try negative 2 to see if the negative 2 is a common factor. Because we still have 8, right? We have 2. And 8 divided by 2. The factors of 8 still have 4, right? And then negative 2. So we pull this 2 down. Negative 2 times 2, negative 4. Add 5, positive 1. Negative 2 times 1, negative 2. Then add those 2, get 4, positive 4. Negative 2 times 4, negative 8. Bingo. Again, we get 0. Okay, that means now we can factor this one into x plus 2 times 2x squared plus x plus 4. Obviously, this quadratic form cannot be factored, so we use quadratic theorem, quadratic formula, right? Quadratic formula is in, you have ax squared plus bx plus c. And we can write x as b negative b plus minus the square root of b squared minus 4ac divided by 2a. So in our case, b is 1 because the coefficient of x is 1. So we get negative 1 plus minus square root of 1 squared, which is 1, minus 4ac, 4 times 2 times 4. Then divided by 2a, divided by 2 times 2. So let me erase the top so I can write here. Simplify this. So simplify, we get a negative quarter. So 2 times 2 is 4 in the denominator, negative 1 divided by 4, negative quarter, then plus minus. Well, 4 times 2, 8. 8 times 4, 32. 1 minus 32, we get a negative square root of negative 31. Well, that's complex, right? So we write as I square root of 31 divided by 4. So we have so find our roots, right? We have 4 roots. And x equal to 2 is 1 root because x minus 2 equals 0. That means x equal to 2 is a root. Then x equals to negative 2 because when this factor equals 0, roots means the function value is 0, right? Then x equals to negative 2. So we have 2 rational solutions and 2 complex. Two rational roots and 2 complex roots. All right, 4 roots, right? Polynomial degree 4 at the most can have 4 roots.